Hello students, in this class we are going to learn about class 9 CBSE mathematics, originating yourself, the use of coordinates. Even in the last class we learned about the coordinate system, the first exercise. Now in the second class we are just going to learn about second exercise, how the quadrants are marked, what are the different quadrants. All these you are going to learn. Now, we'll have a small recap of what we have learned in the previous exercise. Any point, we have a coordinate system. We have x dash, y dash. So these are all the x values. These are all the y values. Both the axes meeting at the point O. Now, right side of 0, it is positive values of x. Left side of 0, it is negative values of x. Same way, above 0, positive values of y. Below 0, negative values of y. Any point on the x-axis can be marked with y coordinate 0. Same way, any point on the y-axis with x coordinate 0. These are all the points we learned in the previous exercise. Now, we are going to moving on to the next topic. So the overall system is called Cartesian plane or coordinate plane or XY plane. So we only consider the points on the two coordinate axes. For example, we had x-axis and y-axis. Any point on x-axis will have y coordinate 0. Any point on y-axis will have x coordinate 0. This is what we learned in the previous exercise. Now, what can you say about the coordinates of points that are not on either axis? On both the axes, if the point is not on the line, then how to call it or how to represent all these? The plane in which the axes are situated is called Cartesian plane. So the axis which is marked on the plane is called either Cartesian plane or coordinate plane or XY plane. These are the different names to call plane. The axis, the two x-axis and y-axis, dividing the planes into 4 quadrants. We know these are the 4 quadrants. We are just going to have the number as quadrant 1. This is the first quadrant. This is going to be the second quadrant. This is the third quadrant and this is the fourth quadrant. So any point in the first quadrant, how it will be marked or what is the symbol? All these we will learn now. So I'm just marking two axes, x-axis and y-axis. Let me name this as x dash, y dash. So both the points are intersecting at the coordinate 0. So it should be equal with 1, 2, 3, 4, 5, 6, 7. All the values which is in the right side is positive values of x. Left side is negative values of x. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Next. Any points above 0, it is going to be positive values of y. So let me mark this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, below 0, it is going to be negative values. So -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10. So if I pick any value in any one of the quadrant, we already learned this is going to be the first quadrant, and this is going to be the second quadrant, third quadrant, fourth quadrant. Imagine you are just going to start anti-clockwise. So this is the first quadrant. Any value chosen in the first quadrant will have positive and positive. So this point is the intersection of positive 3 from x-axis, positive 3 from y-axis. So 3, 3 is a coordinate. So both the symbols are positive and positive. Let me take this point. This is the intersection of 4 and 7. So positive 4 and positive 7. So any value chosen in the first quadrant will have the symbol positive and positive. Now, let me pick any value, any point or coordinate from the second quadrant. So let me consider this coordinate. This is going to be the intersection of, from x, it is -4, and from y, it is going to be positive 3. So this is an intersection of -4, 3. So any point can be represented with x coordinate, then only y coordinate. Let me choose this. So this is nothing but the intersection of -7 and positive 6. So the coordinate is -7 and positive 6. So any value, any coordinate chosen in the second coordinate, the second quadrant will have negative and positive symbol. We'll move on to the third quadrant. Randomly, let me pick this. So from x-axis, let me mark this is -6 and this is -7. So -6, -7 is the coordinate of this. Let me choose this point. From x-axis, it is going to be -4. From y-axis, it is going to be -4. So -4, -4. If you observe the pattern, this is going to be the have the symbol with negative and negative. Moving on to the last quadrant, let me choose this. From x-axis, 7. From y-axis, -6. So 7, -6. I'll choose this. From x-axis, it is going to be positive 3. And from y-axis, it is going to be -10. If you observe the pattern, this will have the sign with positive and negative. So any quadrant chosen in the first quadrant will have positive symbol, second quadrant negative positive symbol, third quadrant negative, and fourth quadrant positive negative. All these symbols we are just marking based on the x coordinate and y coordinate. So this is how the Cartesian plane or xy plane is divided into 4 quadrants, and these are the corresponding symbols. So quadrant 1, both x and y coordinates are positive. Quadrant 2, x coordinate is negative, y coordinate is positive. Third quadrant, x and y both are negative, and fourth coordinate, x coordinate is positive and negative y coordinate. Let us take a 2D plane. Here x represents the perpendicular distance from the of P from y-axis. Let me take this point. This is nothing but x comma y coordinate. Here x coordinate is nothing but the perpendicular distance minus 5. So it is a perpendicular distance from y-axis. X coordinate is a perpendicular distance from y-axis. Same way, y coordinate is going to be perpendicular distance from x-axis. It is at a distance of 3 units. So x coordinate is perpendicular distance from y-axis and y coordinate is a perpendicular distance from x-axis. I hope this is clear to you. Let me take point S. So here x coordinate is a perpendicular distance from y-axis. It is at a 3 unit distance. Y coordinate is going to be the perpendicular distance from x-axis. Now, what is the x coordinate of a point on the y-axis? We will move on to think, reflect. So what is x coordinate of a point on the y-axis? Any point on the y-axis is going to be x coordinate 0. So x coordinate of a point on the y-axis is 0. Is there a similar generalization for a point on the y-axis? On the x-axis? Any point on the x-axis will have y coordinate 0. So this is, for example, if this is going to be the point 1, 0. This is going to be 2, 0, 3, 0. It goes in the same way. Even if you take negative side, minus 1, 0, minus 2, 0, like that. So y coordinate is going to be 0. This is a general point we observe. Any point on x-axis will have y coordinate 0. Does the point y comma x ever coincide with point x comma y? Justify your answer. Let me take a point. I'll consider this point as 2, 3 and this point as 3, 2. I'll mark here. This is going to be the point 3, 2 and this is going to be 2, 3. When will the two coordinates equal? Do you think 2, 3 and 3, 2 are same? Definitely they are not same. It is representing two different positions. So this is possible only when two x coordinates are equal and two y coordinates are equal. So does y comma x ever coincide with p of x comma y? Yes. It is possible only when x equal to y and y equal to x. If x is not equal to y, then x comma y is not equal to y comma x and x comma y equal to y comma x if and only if x equal to y. Is this claim true? When the two coordinates are not equal, when x coordinate 3 is not equal to y coordinate, then 3, 4 is definitely not equal to 4, 3. Suppose if the coordinate 3 and 3 are equal, then we can say coordinate x and y is equal to 3 and 3. This is true only when x coordinate and y coordinate are equal. When x and y coordinate are different, this statement is true. Moving on to first exercise. Exercise set 1.2. We have already learned a few problems based on the same situation in the first exercise. Now this is a continuation of the previous case study. On a graph sheet, mark the x-axis and y-axis and the origin. So let us mark x-axis, y-axis and origin. Mark the points -7, 0 to 13, 0 on the x-axis and from 0, 15 to 0, 12 on the y-axis. So this is the intersection of x-axis and y-axis. Let us mark -7, 0. -7, 0. Next, 13, 0. 12. So this is going to be 13, 0. Let me consider the graph paper. Okay. Okay. Let us mark the points. So imagine we just marked all these. -3, -4, -5, -6, -7, -8. This is x dash. Right side we need up to 13. 7, 8, 9. Okay. Okay, we'll just mark all these points. Imagine this is a graph sheet. So this is not -7, 0. So left side of 0 from up to -7, right side up to 13, we have to draw their axis. Then each and every centimeter, well, let us take as 1 unit. Answer the following question. Place Raymond's rectangular study table with 3 of its feet at the points 8, 9, 11, 9, 11, 7. So 8, 9. 8, 9, 11, 8, 9, 11, 9, 11 comma 7. 11 comma 7. If these are the three corners of the table, obviously this is going to be the next corner. Let me mark this as A, B, C are the three corners now. Obviously this is going to be the fourth corner. The coordinate of the fourth corner is going to be 8 comma 7. Hope you understood. Now, where will the fourth foot of the table be? The fourth foot of the table will be on 8 comma 7. Is this a good spot for the table? Yes, definitely it is going to be the good spot for the table so that it will not disturb the bed or it is not going to be disturb the wardrobe. So it has been kept neatly in one corner. So the table is placed neatly inside the room. It does not block any of the door or any pathway. Moving on to the next, third subdivision. What is the width of the table? The length. Can you make out the height of the table? Is it possible to show the height of the table on a 2D plane? Definitely, height of the table cannot be shown. So this is going to be no. Let us find out what is the width and length of the table. So the four coordinates are, this is 8 comma 9, 11 comma 9, 11 comma 7, 8 comma 7. This is the table, study table. Let us find out the length. Length is going to be each and every centimeter we are going to consider as 1 feet as it is already mentioned. So let us take 1, 2, 3. So the length is going to be 3 and the width is going to be 1, 2. So length of the table is 3 feet and width of the length of the table is 3 feet and width of the table is 2 feet. Moving on to the next question. If the bedroom door has the hinge at B1 and opens into the bedroom, will it hit the wardrobe? If the bathroom door has a hinge at B1, so this is a point B1. Hinge is nothing but okay, basically it is a piece of metal that joins two sides of the door or closed object. So hinge, if we have a hinge at the point B1, it opens the bed, the door opens in the bedroom. So you can open the door here. not through the bathroom. So it can be opened here in this side. It can be opened in the bedroom side. Are there any chances would suggest will it hit the wardrobe? So hit the wardrobe in the sense, imagine if the length is going to be 0.5, 1.5, 2.5. So even if I open the door is having the width 2.5. So maximum it is 2.5. So definitely it will not hit on the wardrobe. Will it hit now? No, definitely it will not hit. Are there any chances would you suggest if the door is made wider? If the door is more wider, if the door becomes much wider, it will come close to the wardrobe. So in this case, the door could be made to open inward in the bathroom. So the door width could be kept limited for the comfortable movement. Moving on to the next question. Look at Raymond's bathroom. What are the coordinates of the four corners O, F, R, and P? So let me have the diagram. I have the question here so that it is easy to look at the question. Okay. What are the coordinates of the four corners O, F, R, and P of the bathroom? O, the coordinate is 0, 0. F coordinate is going to be F coordinate is 9, 0. R coordinate, it is F coordinate is 0, 9. Any point on y-axis will have x coordinate 0, 0, 9. This is going to be 0, 9. R is going to be minus 6, 9. And coordinate P is going to be minus 6, 0. Any point on x coordinate, x axis, y coordinate is 0. What is the shape of the showering area SHRW in Raymond's bathroom? So the showering area is like a trapezium shape. Trapezium will have two parallel sides and the other two sides are non-parallel. So this is going to be the trapezium. Mark off a 3 feet into 2 feet space for the wash basin. So this is the wash basin. 3 feet to 2 feet. 1, 2, 3. 3 feet to 2 feet. So this is going to be the area for wash basin. And 2 feet to 3 feet for the toilet. So 2 feet to 3 feet. 1, 2, 3. So this is the area for bathroom, toilet. Write the coordinates of the corners of these spaces. So the corners are P, Q, R, S, T, U. So the coordinate of Q is going to be minus 5, 0. R is minus 5, 2. S is minus 6, 2. This coordinate is minus 4, 2. This is going to be 5, 2. This is minus 6, minus 6, 5. Other rooms in the house. Raymond's room door leads from the dining room, which has a length of 18 feet and width 15 feet. Length is 18 feet and width is 15 feet. Okay. The length of the dining room extends from the point A, from the point P to A. Sketch the dining room and mark the coordinates of its corners. So P to A, if you observe 1, 2, 3, 4, 5, 6, 6 plus 12, 18. So the complete length is going to be 18. Length is 18 and the width is going to be 15. So from here, let me mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the extension. Okay. Place a rectangular 5 feet into 3 feet dining table precisely in the center of the dining room. Write down the coordinates. So it is just marked 18 into 15. Okay. So if the length is going to be 18 and breadth is going to be 15, so 5 feet and 3 feet can be placed here. Imagine this is 18 and this is going to be 15. As I told you, 1, 2, 3. So let me just mark this 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12, minus 13, minus 14 and minus 50. So the graph can be extended up to this same way. We need to place a rectangular 5 feet into 3 feet table. So 15 in this 5 feet table can be. So let me take 5 unit distance here, 5 unit distance in the other side. So 1, 2, 3, 4, 5. So it is between this point to this point and 3 feet. So totally 18 is going to be the length. 18 we are going to divide by 3. So that's 6. So from here 1, 2, 3, 4, 5, 6. So this is the place where we are going to place the table, rectangular table. Repeating once again, it is a 18 into 50, 18 by 15 room. So 18 divided by 3 will give me 6. So from the left, after sixth, 1, 2, 3, 4, 5. So sixth, same way, 3 unit measurement, same way, 15 divided into 3 parts. So it is from 5 to 10. This is going to be the center where we can place the table. So the coordinates are, let me mark this as A, B, C, D. The coordinates of A is minus 5, comma, any point on x, y axis, x coordinate 0. So 0, comma, minus 5. So this is going to be 0, comma, minus 10. This is 5, comma, minus 10. And this is going to be 5, comma, 5. I hope this exercise is clear. We will see the next exercise in the next class. Thank you. Please give your feedback in the comment section. If you like this, like, share and subscribe the video. Thank you.